Okay. 4x squared plus 7x. Equals this. So what I want you to do is multiply this out and show me step by step that this is the same as this, okay? Okay, so when I factored this for you, which I did here, then ask you to multiply it out. You found that the distributive law tells you that this is the same as this. Okay? This is true because now the way I really want you to see want to see you write this out is just don't write out, well, that's equal to 4x squared plus 7x. Okay, well, no, it's a distributive law, so it's x times 4x plus x times 7. And of course, then that equals 4x squared plus 7x, as you know. Okay, so I'm going to ask you to verify it, do the steps. Okay, now, if you did the thing where you draw the little arc here and a little arc here, I see you're using the distributive law. I'd still prefer you write it out like this, but this is acceptable, but this is better. This reinforces it better. Okay. So if you just wrote this equals this, well, you were right. Okay, but without one of those intermediate steps, either this or both, I don't know for sure that you verified it. Maybe you just wrote this back. Okay, I don't think so, but it could be. So I want to see all the steps. Okay. Now, x squared plus 6x minus 7. Okay, what's it equal? I'm going to give you several candidates. Maybe it's x squared actually I gave you a prime number there. It wasn't a good example. Well, we're just going to verify it. Is this equal? X minus 7 plus 1. I'm not saying whether it's equal or not. Might be, it might not be. So multiply that out using the distributive law. Let's see how this works out. Okay, testing whether this equals this. Okay, well, x minus 7 times this aardvark here is x times the aardvark minus 7 times the aardvark. Okay, so you got x times the aardvark, right there's the aardvark, and minus 7 times that aardvark. Okay, and then that equals x squared plus x here, and minus 7x minus 1. Okay, it's okay to write out the multiplication. You're going to have x times 1 here and negative 7 times x here. That would be good. And negative 7 times 1. And then you can just do the multiplication. You're going to end up with this. Okay. And then that equals x squared. Well, plus x and minus 7x is negative 6x. You have minus 6x minus 7. And this is not equal. So I'll put a question mark on my equal sign. And down here, we compare this with what we started with. So in answer to the question whether this is equal to this, the answer is no. Okay. Because we have a negative 6x here, we have plus 6x here. Now let's try x squared plus 6x minus 7. What if we put the plus 7? Well, we use a minus 7 and a plus 1. Here we're going to use a plus 7 and a minus 1. Okay. Now, why do we use 7 and 1? Well, because these two numbers here are going to multiply out to minus 7. Okay. But we got to get the right two numbers to match up the x term with the x term. Now, the math gives you an algorithm. You factor this into two numbers, that multiply out to minus 7 and add up to 6. Okay. So I'm not going to use that algorithm. I'm just going to use common sense about what happens here. But if you use that algorithm, make sure you remember what the algorithm is, okay? And that algorithm is fine. It's a good way to learn. But we want to see why it works out. And most importantly, we want to see how to check our results. Because I'm seeing a lot of results that are written down without any check. If you don't write these out and check them, you're unlikely to learn to factor very well, okay? As quickly, you might learn to do it real well by following the step-by-step algorithm, okay? But you're not going to get the instant feedback you get from multiplying these out and seeing if they really equal this. And that's where you really learn more quickly. So whether you use the algorithm or anything else, check your work. Always check whether this equals this. This kind of makes sense. I've got the signs backwards. This is going to work. But show me that it does. Now, as I say, whatever you get, you're going to want to multiply it out and make sure it equals this. Okay. And unfortunately, but most people aren't getting to a factor form of this. Okay, so let's look at it. What do these have in common? What's one factor they have in common? 5, right? Do they have an x in common? No, the 25 doesn't have an x. So we can't factor out a 5x. Okay. So what we can do is we can factor out 5. So 5 times what would give you this? Right out. You're going to have 3 terms here. If you multiply each one by 5, you're going to get this, this, and this. What are you going to get? If we factor out 5, then we're going to get 3 terms here. Okay? We're not going to get a parenthesis here and a parenthesis here. That's in another step. Okay? And if we factor out 5, we're going to get x squared plus 6x plus 5. Now, take a minute, use the distributive law, and make sure that that works. You can actually do it in your head, but probably better to write it out to make sure we reinforce and really understand that step. Okay, now, can you factor this? You can, don't even look at that 5. Even if you need to, write this out over to the side someplace and then fill in what you get. Okay. 5 got to be there, but don't let it confuse you. How do you factor x squared plus 6x plus 5? Okay. X squared plus 6x plus 5 factors. X plus 5 times X plus 1. And nobody seems to be getting that. So you want to be sure how you're using open math, okay? Because people that completed this assignment made perfect scores on it. Okay. You made perfect scores on it, watching the videos and imitating the videos. When you get to the problems that don't have videos on them, you really shouldn't have to be looking back at the videos, okay? So make sure if you're using the videos or some other method that you internalize that as best you can, the method, okay? And try to do it without looking at notes. Okay, if you can't do these problems without looking at notes, then you're not learning what you need to learn, okay? That's all there is to it. And I suspect that might be the reason you're getting it now, doing the homework, you're getting the scores, but something's missing, okay? Can't come in here and factor these things in class. It's not like cheating, it's like just because these points aren't really what matters, okay? What matters in this course is developing the skills that you're going to have to use in your pre-calculus course very shortly, okay? Make sure you're developing those skills. And of course, if you're not doing the homework, do the homework, okay? It's how you learn. Your goal in this course is not just to make points, it's to master the skills, or at least get a good handle on the skills so that you go into your pre-calculus class in the next week or the next few days and master them further so you can use them. Okay, so let's verify. Can you multiply this by this using the distributive law? Okay. And then whatever you get using the distributive law here, multiply by 5 and see if you get back to this. Okay. Using distributive law, we'll go from here to here, because all we're doing when we're factoring is we're using the distributive law backwards. It's fairly easy to do that for this problem, but much tougher to do it for this one or this one. Okay. Now, many of you are throwing extra stuff in, trying to do too many steps at once, or making little mistakes on simplifying expressions, okay? 5 is here and we ignore it because we're first going to multiply this by this, okay? So I'm going to put this big set of parentheses around all this. Matter of fact, I'll throw one in here too, just to emphasize that we're going to do what's inside this set of parentheses before we multiply anything by 5. We got 3 things to multiply. You've got to start by multiplying 2 of them. And these are the 2 you want to start with. Okay. So x plus 5 times x plus 1, of course, is x times x plus 1. Plus 5 times x plus 1. Everybody agree? That's your distributive law. Again, x plus 5 times this aardvark is x times the aardvark plus 5 times the aardvark, okay? X times this plus 5 times this. Then x times x plus 1 is x squared plus x, and 5 times x plus 1 is 5x plus 5. Okay. Then we can simplify what's inside. We have like terms, x and 5x can be added, it gives us 6x. Doesn't give us 6x squared because there's no multiplication there. There's no x times x. And I sometimes see that. Now we have 5 times x squared plus 6x plus 5, right? Okay, so we got to be able to multiply these Well, you got to simplify. We multiply this by this. And that works out for this. Now multiply through by 5 and see what you get. So when we multiply this out, we get 5 times x squared, which is 5x squared. And 5 times 6x, which is 30x. Plus 25. And that's written kind of small, but everybody got it. That's, and you see that this the same way. So that this factoring works. Okay. Now you got to be able to do all those steps. Factor of monic polynomial, which is what this assignment was on. Okay. It's always going to be an x squared. And let me just write another one down. Let's put minus 30 here. Seven x. When we factor this, it's always going to be an x here. And an x here. Now, it could be an x plus something and an x minus something, because whatever we have here and here is going to end up being multiplied to give us our negative 30. So I've got a negative here. I'm going to have to have a plus and a minus. Okay. Or it could be an x minus something. Times an x plus something. Now, the two numbers I've got here, and here, have to multiply out to negative 30. What's two numbers that give you negative 30? Show me with your fingers. Give me two numbers, 5 and 6. Okay, that's pretty obvious. There are other possibilities. It could be 15 and 2. It could be 10 and 3. It could be 30 and 1. Okay. Lots of ways that this could be. So we have a lot of possibilities. And when you're starting this, you really need to think in terms of every possibility. But let's start with 5 and 6, because that's what everybody saw me with. Not the only possibility. Let's see if it works. It would be x plus 5 times x minus 6. X minus. I can tell salaries, I can't talk. Of course, that's true the whole year, and I've got other excuses in other seasons. Sorry. Okay. So we could put the 5 with the plus and the 6 with the minus. Or we could put, well, that was ignorant. This is the same as this, isn't it? I can't blame that one out. Okay. X minus 5 times x plus 6. I'm using the 5 and the 6 in the same order, just switching the minus and the plus. That's two possibilities. Okay. If I multiply this out, you see that the distributive law is, after a couple of steps, going to give us x times x, which is x squared. So we've got x squared taken care of. We got a 5 and a minus 6. Well, that takes care of the minus 30, because when we use the distributive law, we're going to end up multiplying 5 by minus 6, right? Well, we're also going to end up multiplying 5 by x and negative 6 by x, right? Okay, so we want to check out, does this work or does this work? Okay, if neither one of them works, then we're going to have two other numbers to multiply out to 30. And as we say, there are 4 possibilities for the way 30 factors. Okay, well, let's just try this one. Okay. Multiply this out using the distributive law. Don't skip any steps. Okay, now everybody's either got this or on the version not getting it. Okay. This is x times x plus 6 minus 5 times x plus 6. Which gives you x squared plus 6x here. And minus 5x minus 30 here. You notice we got our x squared and our minus 30. And that has to be if we use two numbers and multiply out to minus 30 here. And just plain old x is here. Okay. Now the problem is what we get for the x's isn't going to match. Okay. We need 7x. Didn't work. We need 7x. Okay. This. Now, I'm just going to write it out. This is x squared minus x minus 30. And this doesn't match. Right, no. Or ain't so. Whatever we need to write to indicate that this trial didn't work. Okay, well now, pick two other numbers that multiply out to 30. And put those two numbers here. And in the same order, put them here. Okay, two numbers that multiply out to 30. Put one of them with a minus, one of them with a plus. And then do it the other way. Okay, so looks like everybody chose 10 and 3. And that'd be a good choice because it actually works. Okay, so let's put the 3 here and the 10 here, and then we'll put the 3 here and the 10 here. So if you multiply this out, you get x times x minus 10 plus 3 times x minus 10, which is x squared minus 7x plus 3x minus 30, which is x squared minus 7x minus 30. Now you see the 7x doesn't match because you got a minus where you'd like to have a plus. Well, you fix that by putting the 3 here with the minus and the 10 here. Okay. You got a negative here. Well, you see how we generalize that. So we have x times x plus 10 minus 3 times x plus 10. We have this, and lo and behold, okay, and we don't have to try 15 and 2. We don't have to try 30 and 1 because we nailed it. So here we got not quite because of that minus sign. And here we got a yes. Okay. Well, that's trial and error. Now, the method that you're given, and if all you do is follow the method without understanding in detail how you multiply these out, without doing a lot of examples where you multiply these out, without checking yourself, okay? You're likely to forget the method. And again, whatever you did didn't work. If you didn't do the assignment, that didn't work. Well, that's no surprise. You did the assignment and it didn't work. Think about always going back, I've gone to the half credit page and working the problems without looking at any videos, without looking at any notes, day after you've done the assignment, and make sure you really learned it. Okay? Because you think of your goal as, yeah, be able to come in here and solve problems just like the ones you solved correctly on the assignment. Okay? Because that's what I'm going to ask. And that's where I figure out what I'm going to do every day. Okay, I'll ask you a question. You get them right. Okay, takes us 10 minutes. We go on. You don't get them right. And you did the assignment that I know we've got to spend more time on the topic. All right. So I'm not sure all this is visible on the board, but here it is. We used 3 and 10 this way and this way and multiplied it out. This almost worked, so we know we're on the right track. And this is going to work. Okay. All right. Now, I had a question about polynomials. Of course, that's one of our assignments, and you know, we've only got 13 minutes left. Of course, I've got to make judgments about what to cover. And my judgment was we had to get factoring done, at least for these trinomials. You're going to have another assignment a couple of days. Your factoring trinomials that don't have a 1 in front of the x squared. Okay. Now this one didn't have a 1 in front of the x squared, but we took care of that by factoring out the 5, so we could concentrate on a polynomial, a monic polynomial, that's what we call it. It has a 1 in front of x squared. Okay. Okay. Now, if we have a polynomial like we talked about this last time. It has zeros at x equals -5, 2, and 3. So we can start making the graph. We can put a 0 here, a 0 where x equals 2, and a 0 where we know that the graph has to go through these 3 points. I know these 3 points are points on the graph because if I plug in -5, I'm going to get y equals 0. So the point -5, 0 has to be on it. Similarly, the point 2, 0 has to be on it because of this. And the point 3, 0 has to be on it. I'd like to go into more detail in that explanation. I think we talked about this last time. Okay. So we find the intersection. All right, now, if x equals 0, we're finding the y-intercept. If x equals 0, y is -3 times 5 times -2, which is 30. So we have all this information. Also, if we multiply this out, we know we're going to get an x cubed. If I multiply these two, I know I'm going to get an x squared, right? Then if I multiply by x minus 3, I know I'm going to have an x times something with an x squared in it, which will give me an x cubed. Now, if you don't understand that, you need to just go ahead and multiply something like this out. Okay, multiply these out, you're going to get x squared plus 3x minus 10. Then multiply by x minus 3. Okay, it's going to be an x cubed out in front. This x cubed is going to make this thing act like the cubing graph. Okay. And the cubing graph looks like this. Goes through the origin. And it goes to negative infinity this way and positive infinity this way. Bad looking at infinity, it's on the board. It goes to plus infinity this way, negative infinity this way. The graph of this thing is going to look like that, except the fact that you don't have an x times x times x, you got these other numbers, which makes it go through 0 here, here, and here. It's going to have to actually wiggle a little bit. So it's going to have wiggles in near 0. And of course, in the vicinity of these zeros, which means that the graph is going to have to look like this. It's got to go through all these points. It can't go through either the x or the y-axis at any other point. The graph going to look something like this. If you zoom back on it, it looks like this. You zoom back far enough, you can't even see these little wiggles here. Okay. Now, if I give you a graph like this, where this is -2, 0, this is 4, 0, and this is 6, 0. And the graph looks like this. I'm going to just do this. Okay. Now we don't know, I haven't told you what the y-intercept is. But what can you tell me about the function? Well, it's got to be 0 when x is -2. What's that tell you? You're going to have an x plus 2 here. That's what it says. It's not going to be 0 unless you got an x plus 2. I'm assuming that we have a product of binomials, so just similar to what we have here. Okay. If I've got an x plus 2, that's going to give me this 0. What about this one? That's going to give me an x minus 4. What about this one? That's going to give me an x minus 6. Okay. So right there is a function. I don't know what a is. But right there, I've got my 3 zeros. Okay. So we understand that well enough to at least review the video. If that's helpful, or look at what open math tells you, which is pretty much the same thing. You know, open math, unlike my videos, open math doesn't usually show you the person who's doing it, just shows you a string. Okay, you might like that better. You probably like it better than looking at me. And that's fine. I go that way myself. Okay. So they don't show you the fool that's giving you the explanation that every once in a while you get to see this. All right. You know, different style. Use whatever works for you. But don't allow the shortcut process in a way that you don't check it. No, check your work. Okay. Well, anyhow, this is going to work. Now, if I also give you a y-intercept, if the y-intercept is 12, then what?
Okay.
Y is 12 when x is 0. You plug in 0 for x, 12 for y, and you can find a. That's real easy. So you get, well, that's what? That's 48. If 12 equals 48a, then clearly a is 12 divided by 48, which is 1/4. So now, gotta learn to leave myself enough room to write here, but now y equals 1/4 of x plus 2 times x minus 4 times x minus 6. All right, now. You don't have room. You might run over a minute or two. Do this fairly quickly though. Let's say we've got the same zeros. So we've got the same graph. And I'll even put same zeros. So here x is -2. Here x is 4. X is 6. And here y is 12. Now the graph does this. That's really badly drawn. It should be much smoother than that. The chalk got away from me. I wasn't making my turn fast enough. And then I spun the wheel the wrong way and almost went off the road. Took out a couple of fence posts. Okay, but anyhow, there it is. All right, that's a perfectly valid graph. In this case, well, we could say y equals this, just like it was before. But of course, it can't be just this, because if it is, I'm going to get the same solution I got before. Okay. And this graph is nothing like this graph. I mean, kind of like it over here, but you get over here with that little weird thing. Okay. Well, if you look here, this looks like a parabola. Near the point 40. It looked more like a parabola if I had drawn it a little better. That's not exactly like a parabola, it's a little lopsided. Okay. But the closer you get to 4, the closer it looks like a parabola, or should. It's got that shape. Okay, obviously, it's not a parabola when you get over here and when you get over here. But real close to x equals 4, it's like a parabola. And how are you going to get a parabola? A parabola comes from a squaring function. And that means I just shot myself in the foot. That was my last piece of orange chalk. Okay. This is now a blue parabola. I'm going to write a blue 2. Okay. Now it's like this. The x minus 4 squared is going to act just like a parabola close to x equals 4. Like a vertically stretched parabola. And it's pretty stretched. And we'll worry about that later. I'll talk about that for calculus class, but not here. Okay. Especially since we're 2 minutes over already. Well, the rest of it is easy. As soon as you recognize that it actually acts like a square. Now y is 12 when x is 0, so we can figure out what a is. Okay. And we find that got 2, we got 16, and we got 6. That gives us 96. Actually, no more than that. Wait a minute. That's 8. No, that's 16. That's 32. Sorry, I'll go up the backward. That should be 192. And 12 over 192, which is 1/16. So we conclude that get this. It's kind of an easy method. You're not likely to remember the method unless you remember the details of why it's true. And you start remembering those details by understanding how the zeros and the y-intercept are related to these factors. Now there's more to it. But if you understand that much, then you're going to be well prepared to understand the whole picture that you get in pre-calculus. Okay. So if you understand this much, we're okay for this course. And it gives you a real good start in understanding pre-calculus. So try to nail this one.